And we invented Popcorn to help solve the problem of knowing what's going on in our production systems. We'd also like to give a quick shout out to Fernando Benavides from Inaka, who's been an early contributor to Popcorn. Popcorn's fully open source technology, so you guys have access to both contribute to it and to use it. So here's the top view is one you're probably familiar with. That's a logger output. We certainly both use logger, and if you have a small number of servers, hopping on a box and looking at logs works fine. As you scale up, it doesn't work so fine, nor will the system alert you if issues occur. So the bottom part here, you can see that that's the Popcorn view of an alert. In this case, it's a quality of service alert having to do with too many things in the queue. I'd like to point out a few things. You can see that it comes from a queue length monitoring system. It's rolled up how many alerts have happened, and you're able to launch into workflows associated with the alert. And so what we'll do with this talk is we'll present both Popcorn as well as is there like a volume?
Let me see. I think it might actually be check this one. So let me see. I'm not the house AV guy. You can just continue. I'm going to see if I can just turn this microphone off. I think that's...
Yeah, that'd be great. Thank you. So we'd like to show you both what Popcorn is about, how we built it, and then share some Erlang sort of tips and techniques that we used as we went along. So I'd like to share with you Popcorn itself. We're going to hop into a running system here.
All right, you guys, I think I can fix the feedback thing, but there's probably going to be a fairly substantial pop. So give me a second here. Or no pop. That works too. All right, go ahead and talk.
All right, is that better?
Well, for feedback,
okay.
But now let's get this working. Okay, now try it.
All right.
So the microphone's here. When you're looking that way, you're not going to be able to talk into it, so I can move it over here if you look that way more.
That'd be great.
All right. All right, go ahead and talk a little bit.
All right. So what we see here on the screen is a production Popcorn system running at Tiger Text. We've had about 4.3 million events flow through Popcorn. So scalability and sort of where we're at with scalability is something we'll address. You'll see occasional flashes on the screen. This is a system that we've built to have live updates. So that is information being pushed back out from the Erlang server back into the browser to inform that an event has occurred. One of the goals with Popcorn is to, there can be cascading events in Erlang, which is one we just saw. But one of the goals is to have summaries of data and very quickly be able to see what issues are occurring. All right. Popcorn's been used both at Tiger Text, LP, as well as Whisper has used Popcorn. We'd like to just go through some of the concepts quickly about Popcorn and about how we view logging. So first off, just simply what's a log entry? So we use Logger, and Logger provides a host of familiar log items, including module function and line number, which is nice. Popcorn extends that model by adding role, node, and version. So the idea is as we roll out new software, we want to know eventually if the version that we rolled out has had more issues than previous versions. So we want to be able to triage information from rollouts. We're also looking on the roadmap for being able to look at the caller information. Both of our companies deal with custom clients that our companies build that are out in the field. One of those versions may have a different call syntax than others and may cause issues. So that will also help debug issues. This is a pretty standard logger or log message, in this case for rendering an avatar. Popcorn is looking to extend this model by adding information about topics and identities. So this is a Twitter-style sort of log message, if you will. The custom request is sort of the topic that's happened, and it's for an individual user called mHald. Like other systems, we're very interested in rolling up log entries that are critical, that have caused issues on production systems. What you see here are by severity, and we're looking at identifying topics later. Those need to be grouped, so we need to be able to collapse down common strings of text that are related. For that, we need an addressing scheme. So a combination of the Popcorn provided data and the logger provided data, we can come up with an addressing scheme for log messages out in the wild. So in this case, XMPP is the protocol we use, and we have XMPP servers. The particular version of software, the module that had an issue, and the line number give us a unique scheme for saying that this error happened in a particular version and where inside the code. That runs slightly afoul when you get crashes because they have no line numbers. So we need a system by which we can collapse down common descriptions of errors into an addressing scheme. It's a little bit similar to auto-associated memory. In this case, we generate MD5 checksums from the data. The last concept that we wanted to share with you is that of data streams. So with these different building blocks, we have the goal of being able to see large volumes of traffic coming into the log server and sort of pinpoint more precisely exactly what it is you want to see. So, all right. Who here has laptops? Okay. So we wanted to do a fun interactive demo with you guys. I think there's enough people that will try it. In this case, the demo is for a pretend company called Acme Calculators. And they're going to put up a REST-based service, and we're going to see you guys hit that service and see how Popcorn behaves. So we're just going to walk through the process that Acme Calculators would have used to get Popcorn out there. So Popcorn is just a standard OTP application. It's hosted in GitHub under Marc Campbell's account. One simply builds it with rebar. There is one additional step here for optimization purposes. We can compile down the less dynamic style sheet into a CSS file. So that saves the browser from having to do that on every request. Popcorn right now is mostly configured through the app config file, not through the browser. So in this case, there's one password for Popcorn which can be set in the config. And then we can set things like outbound notifiers so emails can be sent if issues are seen. So that was the steps that would be required to get Popcorn up and running. Popcorn itself comes with a Manesia database which will be auto-created when it's launched. So the next steps for Acme would be hooking it into their application. So here we can see a quick update to their rebar config where they include it as a dependency. And the last step that they would then need to take would be to update their sysconfig or app config so that Logger could use it. Logger is a great logging framework, and we've been very happy to extend off of it. You can see here that we've included the Logger Popcorn backend as a handler to Logger itself. So Logger routes log messages to it if they meet the criteria. In this case, debug level messages and up are sent to Popcorn. And then we specify the host and port. And as described earlier, the role and the version are also important. So those are set. So I think what we'd like to do now is I'll bring up the Popcorn UI for the demo site, and you guys can hit it, and we'll let you guys play with it for a few minutes, and we'll get back to our slide and look at some more technical views of Popcorn. So the demo site I'll bring up here, but That curl command, which will be on the screen for a few minutes, is going to be what's going to let you hit the site. It's just a reverse Polish notation calculator. It only takes 2 operators and an operand. We didn't implement subtractions on purpose so you could crash it. There's probably other exciting ways you could crash it if you experiment. And I will bring up the demo popcorn. All right. So is anybody willing to, well, hold on. I did promise to bring up the text, so let me do that. That's going to be slightly helpful, I suppose. All right. So we can see that Popcorn is sort of live streaming the debug messages. Well, the calculator application, which is also an OTP application in this case, is live streaming the Popcorn messages over. We've got a couple debug messages. There's a crash that happened, which is nice in our use case here. If we come over to Popcorn, we can hop over to the main screen, and we can see that we've rolled up those errors that have happened with the minus here. And at the end of the day, Popcorn is about encouraging workflows within your organizations, right? It's about knowing what's going on. It's about being able to remediate what's happened. And it's about sort of tightening the feedback loop between the application and developers. Excellent. We have a very imaginative crash, which is good. Because this was actually an error which was recorded by through a log error message, one of the things that we can do is we can click on source code, and we can actually jump from the error message directly into GitHub, looking at the version of software that was deployed on the servers. So I don't know if you guys deploy very often. We find that the master Git repository that we work with is often different by the time we've deployed code. And we found this to be a very useful way of getting back to the actual source code that was deployed to see what issues that had, so we can patch it. Excellent. So just looking back at this fictitious customer that we created, Acme Calculators, their previous workflow was development puts out code, customers will happily use their product. At some point, if things goes wrong, customers will talk to the support folks, and that information will get back to the developers. That's a very slow process coming out, and there's already frustrated customers at that point, which isn't so good. There's some excellent, application level monitoring and system monitoring tools. Pingdom, for instance, or a host of other ones could tell them if their whole application is up or down. Nagios, they could look at the health of individual servers. But by adding Popcorn to the story, the idea is that they could more rapidly identify edge cases that happened out in production. They could sort of know with good certainty that their system is running healthily or not based on the fact that they're getting feedback from their production Erlang systems. They've got real-time alerting, so they don't need to wait for issues to be addressed to them. They already know what issues are happening. And they're able to interactively look at log streams, both in terms of what's happening in production as well as for things like development and working with other groups within their company that might be using their product. So that's my little part here. I'm going to hand it off to Marc Campbell, who will talk about popcorn design and show some of the interesting techniques that we use to build it. Here you go, that's off. That's the mic for the room. And this is the mic for the camera.
Thanks. Yeah, so I just wanted to talk a little bit about some of the technologies that we're using inside Popcorn and what we use to build it, how we're using it, some of the problems we ran into. I think it's cool how we did it in Popcorn, and it might be beneficial to anybody else working on similar technology. The three parts that I want to talk about are how we're ingesting messages into Popcorn, how we're storing them, and how we're rendering them back in the browser efficiently and effectively, with a focus on scale. Starting at the beginning, how we're ingesting the messages into Popcorn. As Martin mentioned, right now we're using a custom backend logger, which takes the message, the log message inside Logger, uses protobufers to encode it, and UDP sends it over to the Popcorn server. We're doing the same right now in Winston, which is a Node.js logging framework, and also we've started working on one for Log4j. It can really be used in any logging framework that's out there as long as you can have access to a UDP socket and you can use a protocol buffers library. There's downsides to UDP. Packets come in out of order. We might drop some, and we've kind of built Popcorn up from that in order to handle the scale that we need to. And by scale, I'm talking about specifically like how many messages per second we can handle. Right now, the system that I'm running on one medium instance on EC2 handles about 500 messages per second, pretty much 24/7, and it handles it fine. How we're getting the messages into Popcorn. Once all the clients on the left here, they protocol buffer encode the message and send it over the UDP wire, over the socket. We have a single UDP listener inside Popcorn that receives the message, decodes it really quickly with no hits to the database, very fast, and then spawns off finite state machines, one for each node that we're monitoring. Each node is responsible for its own triaging of alerts, logging to the database, sending it down to the clients, whatever it needs to do. The idea is that the UDP listener that we have it has to stay really short and quick because right now we don't have a pool of them, we just have a single one. Once the node finite state machine gets the log message, it needs to store it into the database. We designed the storage system to be pretty modular. Right now it's using Manesia. 500 messages per second works fine. There might be somebody who wants to use React or Redis or MySQL or anything else on the back end. So what we've done is we've defined a simple behavior that you have to implement in a gen server. If you've implemented that behavior, you can swap out the Manesia in a config file and then use any other backend that you want. You have to meet very specific requirements. So what we've done is it's a pretty typical gen server, if anybody's written gen servers in Erlang. We do pool them. We'll start a pool of normally 5 of them to start with. We have 2 different ways that we can create your gen server. One is just to deserialize any previously saved data that you're responsible to do. And then worker processes, which we'll start. And then there's some synchronous and asynchronous calls, handle call and handle cast, that you have to implement. The asynchronous ones we try to keep pretty minimal. Obviously, anything that we want to be able to do 500 messages per second or more, which turns into 40 million messages a day, we can't have a lot of synchronous code running, especially with the way we have it designed with one finite state machine per node. So the synchronous calls are stuff like, we need the value of this counter, or does the database know of this node? If not, create it. Events like that. These are pooled, your gen servers are, for the storage handler that you're writing. So you can't really cache inside there for counter values. Make sure that, we actually have implemented a caching layer and a buffer in front of this inside Popcorn. The big ones on the asynchronous methods are new log message. Every time a new log message comes in, we're going to call in and you have to store it to the database. And the top one, which is expire logs matching. Popcorn has like a log retention policy per severity level. And you can tell it, I want to hold debug messages for 5 minutes and critical messages for 2 weeks if you want to, or whatever. And we'll call into your worker processes to tell you to go delete those when needed with a severity and timestamps. It's kind of how we've implemented the storage. Going on to how we're working on getting it displayed in the browser. We're using a technology called server-sent events, SSE. It's a little lesser known W3C standard out there. It's similar to WebSockets, but it's a single direction. WebSockets allows the client and the server to communicate. Server-sent events allows the server to push data down to the client, but the client does not have a way to talk back to the server over that same channel. So the client has to open up another HTTP post or some out-of-band communication mechanism. Once the server sends messages down to the client over SSE, it can send it in any channel that you want, in any data payload that you want. The examples on the bottom, there's a channel for alert and a channel for a node, and we're choosing to JSON encode the data payload that we're sending down, but you can really do anything there. This is an example of the JavaScript client-side code to handle the server-sent events in the browser. This just responds to 2 different channels, update counters and new node, parses the data, and then we'll pass it off to whatever it needs to do. On the server side for the server-sent events, we're actually using Cowboy for the HTTP server, and the way that works, it's we have the node finite state machine running, and then when the browser connects to that log streaming, it calls into Cowboy web server. Cowboy spawns a process and goes into a receive loop. Then it creates a log stream finite state machine as a separate machine, registers that into, right now we're using an ETS table, and that finite state machine has all of the parameters for that stream. It might be what severities you have filtered out, what timestamps you have filtered, whether it's paused or not. It registers that into the ETS table, and then when log messages come into the nodes broadcast them out to, just using standard Erlang message passing, it'll broadcast them out to all of the log stream handlers. Log stream handlers check to see if it's filtered out, if it's relevant data for that connected client. If it is, it passes it back to the Cowboy handler, which is in that receive loop. The Cowboy handler just SSE encodes it and sends it down over the existing connection. And we're able to do, like I said, 500 messages per second, and we're able to really keep that up through an SSE stream over a normal internet connection also without taxing the browser too much right now. SSE, when you're using it, it's kind of a different technology. This is like when you configure it with Nginx on the front end, you have to make sure you have proxy buffering off. You can use stunnel, you can use HA proxy, you can use different technologies on the front end of server-sent events. But the point is Cowboy supports it, and Nginx and most of the common proxies out there do. The wire protocol, I've talked a little bit about some of the standards that we're using, from server-sent events to UDP to protocol buffers, and I want to focus a little bit on protocol buffers versus JSON encoding the messages. When we're sending the messages through protocol buffers, if anybody's not familiar, protocol buffers is just a standard that Google has created. It's a very efficient and compact representation of data. They're typed and ordered packets, but they're binary at the end of the day. This is an example of Erlang encoding a protocol buffers packet. The same packet in JSON looks like this using Jiffy, which is a C extension for JSON parsing in Erlang. Both of those packets converted to the wire format look like this, with the protocol buffers one on the top and the JSON one on the bottom. The protocol buffers one, as you can see, is significantly smaller. The JSON one, there's advantages to JSON. It's more extensible. It's definitely more human readable, but it's bigger. So what we decided to do was spend some time figuring out if JSON is good or if we should go with protocol buffers for this solution. This is using Jiffy for JSON and the Erlang protocol buffers fork that Basho has actually for the protocol buffer side. We encoded and decoded 1 million messages just on a typical MacBook Air. And you can see the processing time is really about the same. Encoding is almost identical, and decoding protocol buffers is slightly slower than the JSON ones. But the big win was with the memory overhead per message that we needed to handle. JSON used a considerable amount more memory. And we could optimize that a little bit by shortening key names or doing something like that inside JSON, but I mean, protocol buffers is more efficient just out of the box, and it's going to be because it doesn't have those key names in there. So we decided to keep protocol buffers. And then the next part was a little bit about how we're rendering in the browser. What you saw so far was just the log streaming coming in, and that's just DOM events manipulating inside the browser that we receive through the server sent event stream. There's another URL, which we'll show you also. Actually, the next slide has a preview of it, where we're starting to use some D3 visual representations of the data. So you can easily look at the screen and say, on your dashboard screen or on your log screen and say, you know, hey, all my events are coming from a single server or from a new version of the software or a role, or I have a lot of critical messages and not a lot of debug, or, you know, something out of the ordinary. So we're using D3 to render that, and Square has a JavaScript library called crossfilter. I don't know if anybody's used that. It lets you take a large data set inside the browser and basically do reductions and map reduces inside that in the browser. So we're using that, and what we do is we can produce a screen that looks similar to this. On the top, it's a D3 graph where it's just the log volume over time. And then you can see, you know, this is a beta, so we don't have, the UI is not totally done. There's labels missing and stuff. But you can see the severity in the roles and the nodes, and as they're coming in. The idea is to extend this and allow you to select a time frame on the top of the screen, and then the graphs down below that will reflect the message volume inside that time frame. And then down below that, the log messages show you the raw log messages that made up the stream at that time that you were looking at with the filters that you have selected. So going back to scaling a little bit, to get to the point where we are now, we have to keep going. You know, 500 messages per second on a single server is good. We want to keep going, and we need to get it to a distributed state and be able to handle larger and larger clusters of Erlang servers. Before we could figure out 500, we're happy with because that hits both of our criteria very well right now. But before we could even get there, we had to figure out where our bottlenecks were, because the first time we wrote it and we launched it, it wasn't there. So we had to identify some tools and build some even in order to figure out exactly what the problem was that we had to solve. So one of the biggest tools that we found is StatsD and Graphite. This is actually a screenshot of Graphite logging StatsD data. We wrote a little module called RPS, which basically is just a request per second library, an application inside Erlang that you can install in your app, and then you can pass messages through to it. And it's just designed to like basically keep really simple counters and pass them through to StatsD, which Graphite can graph, in an efficient way without impacting the performance of the monitored application too much. Other tools that we used are DTOP. DTOP is built into Erlang, where you can monitor or connect to a running console and then watch the gen server or gen FSM, queue lengths, reductions, CPU, memory, overhead, the current function that a gen server is running right now, how many messages are in the queue. Redbug is another one. Redbug allows you to connect and put a trace on a running system. Probably wouldn't want to do it on a production system, but you could. You can see you can give it a function name or a module and ask it to trace to the console any in real time calls that are made into that module or function with the parameter names, and you can actually, it's really helpful to help track down exactly why something's crashing or where problems are coming in. And some other tools that we used. So at the end of the day, you know, we found 3 big issues that we needed to fix in order to get to the level that we are right now. Our Manesia database wasn't scaling as well as we wanted it to. We had issues with just receiving UDP messages, and the client could, after about 500 messages, Chrome stopped responding. And so we had to make that a little bit more efficient. We liked Manesia because it came out of the box with Erlang. No, there's no need for an external database server, nothing else that anybody would need to set up. We both liked it, and we know Manesia can handle the volume, so we had to troubleshoot and figure out what the problem was. When we started, we were creating indexes on our log message on almost every record, or every field in the record. It was severity, it was role, it was node, it was timestamp, it was everything that we thought you might want to be able to filter from the browser. And as you can see, it turns out that it's not very consistent time inserts. As this graph just shows 5,000 inserts into the database in a very short period of time. And you can see each insert took longer and longer. So that wasn't going to work really well for us to get to a system that can handle 4 or 5 million messages. So just to confirm that indexes were the problem, I removed all the indexes from the database, from the Manesia table, and reran the same tests, and it became very consistent time inserts, constant time inserts, but the system's no longer usable. You know, those indexes were there for a reason, so we had to find a solution. Adding just one of them back in which we added I added the severity index back in. There's 8 possible severities in a logger log message. It looks a little bit better, but it still has the same problem. 5,000 messages. The y-axis is a lot shorter now, so they're not taking as long, but it is still growing, so that's a problem. Taking that severity index out and adding just an index on timestamp, it becomes very good. The difference between timestamp and severity index is there's 2. Timestamps are incrementing, and they're microsecond timestamps, so they're very, very distinct. Severity indexes are all over the place. There might be a lot of 1s and then a lot of 8s, and then they're also a lot with the same value. So what we decided to do was keep it this way and just kind of re-architect the way that we're rendering the data and how we can query it on the browser to work with a timestamp index, which actually works really natural for log messages anyway. So then the last one was the browser. Like I said, 500 messages would eventually use up all the memory on the browser. So we did some work. We ended up actually with 2 SSE streams right now in the beta version, the beta UI. There's a line that we're trying to figure out where we can filter on the server versus filter on the client. Filtering on the server, obviously, there's a trade-off. It's more load on the server, but we think that there's the benefit to be able to do both. Right now, using cross-filter and D3 to render the data, we're past that 500 message limit, but we still need to keep pushing that forward a little bit more. And as moving forward, we want to be able to add filtering on the server and the client, and I think that's where actually the power is. You want to show the beta screen up?
Yeah. So we'll flip back to the
Sure.
Chrome. We should also say that you guys can log into the demo website. The username is just the default admin password. You're free to log in and play with it. You're even free to take your application and configure it to send the data out if you want. So just because it's not totally done yet, we kind of put it on a URL with beta equals 1. And we'll see if it works.
You can go full screen on that.
Okay.
Drag it over.
So as log messages come in, what happens is the graph on the top will show up, and then these don't have labels on them, but these are D3, just pie charts showing the severity, then roles, and then servers. And then down here, you actually still have the log messages coming in, filtered down to that. So that's it. End of the presentation on Popcorn.
Do you guys have any questions or?
Have you done any grouping? So if I consistently get crashes in a particular handler, but on my website or something, are you able to sort of group some and say, oh, you had a whole bunch of crashes in that area of your code and then a small number in another area?
Sure. Yeah, we do. We can, if it's a log message that's causing that you can have an error or an emergency or a critical handler on it, we definitely can. Logger can provide us a lot of information about the line number, the module, and we can group that very easily. And Martin's done some work on just Erlang crashes, which don't have line numbers in them.
Yeah, we are. So right now we use a simplified model where we sort of generally know the structure of a crash and the kind of data it provides, and we can filter out the data that would be dynamic, and then we have like a coherent set that we can create that checksum from. So yeah, that's the checksum. We realize that there's probably machine learning techniques that we'll have to use down the road, but our ad hoc method actually works very well.
You talked about, you showed a feature where you click to get to the source for the right version, it looked like, and I was curious to hear a little detail on how you link what you're using to identify a version and how that links together.
Sure. So we have a bash script that we can use in releases called git_svn, I think. And what it does is it uses a find command to recurse and find all the Erlang modules, and then it looks to see what. So it'll look both in the deps folder, for instance, as well as your source code, and then it figures out what Git project they're part of, and which actual what's the latest log head checksum, and then it builds a submit file all in JSON, and then when a server launches, it can simply submit that to Popcorn, and that technique has worked well. You basically have to know a priori though, what that is.
So
look it up.
basically you release a version 1.2.3, but with that you provide a manifest for the
Yeah.
GitHub URLs and Git shells.
Right, and we use Chef to release source code, and so it's simply just a part of our like build and deployment process.
Are you using Ranch for your UDP socket handling? And if not, why not?
We're not right now. Like, that's definitely on the list. We want to be able to use Ranch and pool them, and like, there's a lot of optimizations that we can still do there. Right now, you know, we're not dropping UDP packets, but I think, you know, to get it to the, like, we're probably pushing the limit on what we can do in a single gen server right now.
So I'm curious about how you store the stuff underneath it. You've got your index and timestamp.
Yeah.
So you just periodically do a query to select everything older than a certain time and delete it, or read it. Is that how you're pruning it?
Older than a certain time and with certain severity levels. Because, you know, like for me, I'm sending sending all of my debug messages even over to it for some of the servers. And I don't want, there's a lot of debug message traffic, and I only want those to last for 5 minutes. It's definitely for debugging stuff.
You found it's quite expensive to do a mass delete for a piece of
Initially, yeah, there was.
We rewrote that code
Yeah.
several times.
Yeah.
There was.
Are you doing any tricks to make that more efficient when you have to delete a whole ton of data?
I mean, I don't know, any tricks?
What do you do?
Possibly.
Do you just select all the keys up within a certain time and just delete them all individually?
No, we definitely aren't doing that. There's some parse transforms that are written inside there to help make it do it. If you're curious, I mean, the code is just up there in GitHub. Definitely take a look. It's all in a single file, so.
How does the performance of the regular Logger client compare with your guys' custom version of Logger that perform this additional push to this other data stream? Is there like a performance hit you have to take in order to use this system that you guys are aware of? Or?
Well, it's definitely going to use up CPU to like serialize the data and send it across the wire. We look at on our production systems, like we look at like the number of like reductions on gen servers across the system. Logging is normally somewhat up there, even with just Logger by itself.
Yeah.
But by no means does the Logger popcorn backend get any worse than Logger itself. Logger uses gen event in order to have many event handlers and then broadcast to them so they can each handle the event in the way they need to. So we haven't changed Logger. We've simply used one of its extension mechanisms.
Okay.
And the way the handlers work, you know, you can have debug messages going into Logger, and you can just, in the handler, you can specify a different minimum severity for each handler. So
Right.
you can definitely like say, I only care about errors and above for popcorn type stuff.
Do you have some upper end throughput numbers or connection numbers? You mentioned that you were doing 500 messages a second on your EC2 instance, but
Right.
how far have you guys pushed it from a velocity perspective?
Yeah, we know we can survive 500. We don't know where it breaks right now.
I mean, we work to get to 500. I mean, you know, it's probably not that much above that is where it would start to need some additional work.
Do you have a mailing list or something for submitting that, or you guys prefer info on the GitHub repo?
Yeah, I mean, GitHub repo is great.
Yeah, we're also happy to share our
Yeah.
email after as well.
I've lost it, sorry.
All good?
Well, when you remember in a minute, hit us up again. You know, I should say this, we've been building this for ourselves. You know, LivePerson uses it, TigerText uses it, Wisdom uses it, but it's also fully available for the community. So we would also be interested in hearing, you know, how well does this match your current use cases, and you know, what are the next most exciting things on your list?
So one of the problems I've had in the past with logging using Laravel and stuff is if you suddenly have an explosion in like crash reports and satellite reports and stuff, just like rendering these things straight is really expensive. It consumes some memory and stuff. So I think React has some kind of error truncating thing. Have you had any problems like that where you suddenly have a massive CPU load increase because you have to render all these log messages?
Not to, but I think that's part of what Logger is doing perfectly.
Yeah, Logger does truncate things by itself, which can sometimes be frustrating actually, because then you're like, you know, but this was beyond the truncation point I really needed that data. So you can also configure it, I think, to give you more.
Right.
Do you ever just make a decision to just sample the events? Like, in addition
Yeah, it's a great idea.
It's definitely a good idea. Well, like, you know how many requests per second you're getting. If you're getting more than a certain number of requests per second, you drop the number of actual log messages
I
you
think
ingest.
there's also a patch that Fred and Andrew were working on for loggers to, in that particular scenario where there's multiple duplicated errors, just class them into one and just say, here's one single.
There's another good possible efficiency is actually bulk uploading, larger packets, right?
Yeah.
I mean, in terms of using this as part of your, metrics and monitoring stack, I mean, I guess I'm curious how you find you're using the history and how much history you're using. So, like, we use Graphite for a lot of our, like, we're pushing data into Graphite, and so when things are not going well, you can look at both what's happening right now in terms of the graph, but you immediately have as compared to what, like this is what the graph looks like over the past 5 minutes, and here's what it looked like over the past hour or yesterday. And I'm curious how you see this stuff. Like, do you imagine this is going to be enough because you're able to configure enough and it's sort of a replacement for something like Graphite, or do you imagine time? I don't know.
I think this is part of a larger ecosystem, right? So I wouldn't look to replace Graphite. And Graphite has a very particular use of rendering arbitrary certain types of data. The way I use this most is I look to see, the question is what issues have happened out there? What are the current issues? What are the most frequently occurring ones? And which ones have happened most recently? And those are two questions that I always want to know the answer to. And that often also sort of informs if there are issues that engineering needs to look at, that we can proactively start on those.
That said, that's one of the reasons we're adding some of those D3 graphs into there, because I don't think it's going to ever replace Graphite, and that's not our intention. But I think if you can filter the messages down to a certain time frame and then down to a certain server or role of servers, and you see the raw log messages in those graphs, it might help when you're looking at Graphite.
Popcore is still an early technology as well, so as it matures, having those graphs on the various pages, a picture really can't say 1,000 words in terms of getting a very quick understanding of where issues are.
Right. I mean, so is it? But I mean, so I get like you're able to answer some aggregate questions about events, log events, but then the question is like, how do you correlate those to the server's performance in terms of response time?
Yeah, and one of the things that's kind of, we haven't even started on the code really yet, but we've been talking about is adding heartbeats into the Popcorn server. So the server can send gauges, kind of the same way StatsD and Graphite has gauges. You can have some of those events through, and that's outside of Logger, but it's just a separate TCP connection that your server through the Logger Popcorn backend or a different module can make, send that data up. But when the Popcorn server sees the raw log data and it also knows these heartbeat data and this gauge data, it can correlate that. But that's just something that we've been talking about, but we haven't done it yet.
All right.
Cool.
Thank
All
you
right.
all so
Thank
much
you.
for coming and listening.